Greetings. This is Infinite Series lecture number 2. In the first lecture, we have learned about what is sequence, what is series, and the three type of infinite series, that is convergent series, divergent series, and oscillatory series, and their definition and how to identify them. And also we have learned geometric series, but in that topic we will learn about tests to find that a series is converges or diverges. We have four tests. That first is our comparison test, and then is our Cauchy's ratio test, Cauchy's root test, and Cauchy's or Maclaurin integral test. We in this lesson particularly we just will read about comparison test. What is basically a comparison test? That is basically we compare with a given infinite series with some known infinite series, what we know that that series in converges or diverges. Let's do it. Suppose if we have a series to find that whether it is converges or diverges, then we will find another series bn that is more than the an, and an is the from 0 to bn and will belong. And if we have that this series is converges, then we also can find that this series is also converges. If that bn converges, then sum of an also converges, and if the sum of n diverges, then the sum of bn also diverges. This is called comparison series because comparison test, because we find that result of that test by comparing with another infinite series. Now the theorem for application of comparison test. Suppose we have a series un, sum of un, and another series sum of vn, two series of the positive term, that means the more than 0, such that limit n tends to infinity un by vn is equal to l. This l should be a positive term more than and non-zero positive term. Then that both series will either converges or diverges together. If one of them converges, then both of them converges, and if one of them diverges, then the both of them diverges. The proof of this test has been attached in our study material. You can go to our description link, there you can find the proof. Okay, next take an example how it happened, and then we will understand it better. Example, the test series sum of root over n by n square plus 1 from n, the limit. Now we have this series given that root over n by n square plus 1. Now take another series Vn is equal to root over n by n square. Uh, this is can be written as 1 by n by 3 by 2. This is structure, this structure is the structure of auxiliary series, that can be written as sum of vn can be written as sum of 1 by n of n 1 by n to the power 3 by 2. This is the auxiliary series. Now we can write down one more thing, auxiliary series is convergent series. Okay, we can prove. Now let's in that series that un by vn can be written by written root over n by n square plus 1 into n by 3 by 2. So it can be written by n square by n square plus 1. Okay, now limit n tends to infinity un by vn is equal to limit n tends to infinity n square by n square plus 1 is equal to limit 1 by just divided the denominator and numerator and denominator by n square 1 by 1 plus 1 by n square. Now look at the term. If n tends to infinity, this term will be very less, that can be tends to 0. So the we can find the value of limit is 1. It is a finite value. In the previous lesson we have learned that if that limit we get is finite, then that series is convergent. As So that series, if it is convergent, then this series is convergent series, and auxiliary series is convergent. Okay, so this series is also convergent. Now how can we say an auxiliary series is convergent? Look at the structure. If this n tends to infinity, then this whole term tends to 0, and if any term tends to 0, then it's called a convergent series. Okay, now in the next lesson we'll learn about D'Alembert ratio test, and if possible we'll learn some example and we'll solve some problem too. Thank you so much. For your convenience, we have attached and study materials. You can go for it. Thank you.